Next up is Churn, data science lead at Grid Dynamics. He will tell us about preventing customer churn using prescriptive models and deep learning. Remember that you can view and download a presentation deck within the console resources icon. With that, I will hand it over to you, Jake.
Hello, everybody. My name is Jake Churn, lead data scientist from Grid Dynamics. Today, I'm going to share with you a study that we have recently done with churn prevention. So let's jump into the topic. So before showing you guys what we have done, I want to show you guys what we want to ask in a churn-related problem. There's fundamental questions are important in order to understand churn. I think like most researchers, they tend to focus on the accuracy of the prediction, but this is just one side of it. We should really also understand the churn reasons and trying to find solutions based on those churn reasons. So the four fundamental questions are the four W's showing in this slide. First question is who will churn? We need to understanding the customer space who's at high risk. And if we understand that, we can optimize our treatments and we can even personalize our treatment if we understand the customer risk at account level. The second question is when the customer will churn. So this is a question that related to churn modeling. If we have a good model prediction, and then we can understand when the customer will churn. And this will improve revenue management, like corporates will have a better idea of their cash flow according to the churn risk they are seeing. And the third question is what I think the most important question to ask in finding a churn solution is why customers will churn. So finding the churn reasons is very, very important because it helps the business to understanding the reason that their customers are churning, and they can drive their business strategy based on that. They can decide some promotions or offer bundles. If they understand the churn reason well, they can decide very good bundles to save their customers. And once we understand the churn reasons, we can take a step further and pick the best offer. A lot of corporates will have prefix bundles, offers in the offer space, and they would provide those offers to customers. But say if they have two offers, right? Say they have offer that can reduce their price plan. They can also have an offer that can give them free device upgrade. If we understand the customer is not happy about the price, we don't want to offer them a free device upgrade. We want to offer them a discounted plan price. So the offer model will help corporate to understand which offer has the best chance of winning the customer back, and this would definitely improve customer satisfaction and improve customer experience. So once we understand the four W's, then we're going to the model architecture. First, we would need some data to start with. We would need user-generated content. So an example will be a call transcript, like customers call to the call center before the churn event and express their feelings, most of the time the bad feelings, and they're trying to say something that they are unhappy about. So this is very valuable information. We can use a sentiment model to capture that and hopefully review the churn reason. The second data is the account data. So this is just account level characteristics data for the customer. The third data is behavioral data. This is customer journey data. Before the churn event, customer can have a sequence of a lot of events happening. For example, he can go to a store and ask for some technical help. He can go to a website and browsing some URL. So those data we can study. We can use a transformer model and to study the pattern of the behavior and find out which one leads to churn. So and the fourth data that we want to have is the treatment data. So it's the treatment offer history that reviews how customers are respond to different treatments. So once we have all the four data ready, and then we can have the two-layer model. We build four models in a two-layer setup. The sentiment model is utilize the user-generated content and account data. This is basically trying to find out who is at risk and why they will churn, finding churn reason. The event model is served for the similar purpose, except that it's utilizing behavioral data instead of user-generated content data. And the survival model, obviously, is to answer the question when the customer will churn. So you give a prediction on churn or prediction on survival. On the second layer, as we can see, we have some outputs from the first layer model. We will have the churn triggers. We will have the short-term churn prediction, the long-term churn risk profile. And then we also have the treatment model, which will answer the question, what are the best treatments? So together with that, it all feeds into the downstream system and processes. Each company will have different processes they're trying to use. So basically, they would just utilize these results and either figure out a systematic way or a personalization way to prevent churn using our model outputs. Next thing I would do is I would look at each model. We will talk about each model independently. So first, let's jump into the sentiment model. So in a nutshell, the sentiment model is just taking the call transcripts and feed it to an NLP bot, and then output the churn reason. And business can use the churn reasons for two purposes. One is the systematic treatment. The other is personalization treatment. Both treatments are similar. The only difference is the target. In a systematic treatment, we are targeting a group of customers that share the same level of risk and also share the same level of churn reasons. And then we pretty much like everybody gets the same offer. And on the personalized treatment, which I think is more advanced and probably requires more accurate prediction, it's pretty much similar to one-to-one marketing. You pretty much offer the customer based on the churn risk that you see from this customer and the churn reason you see from this customer. But obviously, it requires very good accuracy at the customer granular level. So this is a more detailed methodology on what we do in the sentiment model. So there's two main models running inside the sentiment model. So first of all, we want to extract the negative snippets. So the negative snippets are the bad sentiments that customers expressed during a call or interview. So the customer will have, so we put an example out there. So the customers began with like good sentiments, which are in the green lines, and then it drops to neutral. And then on the orange lines, it starts to have bad sentiments. So our model would be able to capture those words around the bad sentiments. And then we feed to the second model is the topic modeling. So topic modeling is just a clustering model and outputs clusters that have similar topics. And once we get the similar topics, we would have some manual labeling and actually look at the output is a bag of words. And we would look at those words and trying to understand whether it's a meaningful churn driver or churn indicator or just noise. So this is what we do in the topic modeling. So coverage-wise, we have seen about, after the negative snippet extraction and after we filter out noise, we have seen about 30 to 40% coverage. This is pretty good coverage from our model. And then the also list some of the common words, common categories that we have seen in churn labels. So for example, like in price-related issues would have high prices or payment terms. So, people are just unhappy about, different things. And then I think we can jump into the next model, the event model. So as I said before, the event model is utilizing a sequence of events before churn in the user journey. So first of all, I want to talk about the input data set. Because there's a couple of modeling that we can consider, and we find the transform model has the best performance. But there's a limitation on the transform model. It takes fixed length of events. So we can have a user that have 100 events, another user have 58 events. So what we do is we kind of fix the latest event first. So that is the last event in the sequence. And then if a user have more events than the fixed length we decide, we just cut it. If a user that have less, we would use some padding zeros to get it to the fixed length. So in this way, the transformer model can run and provide results. This is just showing the transformer model setup. So yeah, I'm not going to talk about all the details on the modeling, but I want to talk about the benefits of the transformer models over LSTM. So first of all, the transformer model is self-attention model, and it used to, I think the original purpose is to do translation. So one advantage of it is it sees all words simultaneously. So in our case, it would see all the events simultaneously. So unlike the LSTM, it would do like word by word and do a backpropagation setup, and transformer would be seeing all words simultaneously. And when you're running training inferences, it's just very efficient. And also, transformer is less prone to vanish gradient problem, which is a very good thing. And more importantly, it has very good explanatory power because it uses self-attention mechanism, so it's highly interpretable. So this is the steps that we use to identify the churn reasons using transformer model. So first of all, we need to define the most important and frequent events. Usually, in our study, typically there should be between 100 to 1,000 events that should be important and very frequent. And then once we define those events in the population, we can compute the attention values associated with these events, so which is showing in the on the left side of the chart. So we would have self-attention weights. And then we would use clustering techniques. We use k-means here. So basically, you use k-means to cluster based on the self-attention weights. And then the final output will be the user cluster, where we get, pretty much one cluster is the users with similar activities or a similar combination of user journey patterns. And then we can figure out maybe from the frequency of the events. And then we can look at those events and figure out whether this is a meaningful churn reason or this is a not meaningful churn reason. So we can decide based on our understanding of the business. So let's jump into the survival model. So survival model, I think this is a very, very common topic. There's a lot of traditional models that's available, like the cost proportional hazard, the accelerated failure time model. Those are the two traditional models that we evaluated. I think like those are good in terms of like it used to be like good in terms of like setting up the model in a parametric way, but obviously like it will miss the part that that when the feature is affecting the churn risk differently throughout the time. For example, like cost proportional hazard will assume a constant hazard rate. So it would not take effect into that, if a feature that just have different effects throughout the time. And the same as accelerated failure time model. We do find random survival forest tree is somewhat a good model, but the problem with that is, the deeper the trees, it's just like we're getting smaller and smaller significance. Also, it's very computationally expensive. So unless you're running some GPUs or you don't care about how much running time, I would say this is not a recommended method. So the best method that we find is the binary classification model, and we actually use CapBoost here. What it does is it treated each month as an independent scenario, and based on the binary classification, we would just build our model on each month. So if we say have a 6-month prediction, we would have basically 6 binary classification model running. And then one interesting thing we find is that in addition to our base features, we include some extra features that highly improve our model performance. So those features are from the previous event model and sentiment model output. So basically, if we put like the churn risk, the churn drivers into that binary classification model feature, it would just greatly improve the model performance. Yes, so here it comes our last model, which is the treatment model. The treatment model is basically using uplift concept to try to calculate or estimate the churn impact based on probability of churn given treated or probability of churn given not treated. So the idea was that in the training stage, we would have treaty group and control group as input, and then we do some bias correction, which are very important because most of the time you're facing a problem that when you have a control group, there's some selection criteria already there. So it's not exactly, unless you do an A/B testing, it's not exactly apples to apples. So we need to run the bias correction, and then we use the survival model for the training session, and then on the inferences, we also use the survival model for the inferences, and then we would output two probabilities, right? The probability of term given is a treaty group and it's a control group, and then we're able to take the differences and calculate the uplift, which is the term impact estimation. So based on the term impact, we can then run our offers and based on that and pick what is the best offer that we can give to the customer. And now I just want to talk a little bit of the bias correction methods. So why we use bias correction instead of A/B testing? Because A/B testing is super expensive and usually time consuming. So an alternative way is to use statistical methods. So in our study, there's two methods that I would recommend to use. They are similar methods. The differences is propensity score matching is quasi-experimental method, so it's actually constructing a treaty group and a non-treaty group. And then the Hammond method is more of statistical method that correcting the mistake. So it's using a probability regression to predict the probability and then corrects the self-selection in the second step. And then this almost concludes my talk here. So at the end, I want to give you some key takeaways. So first of all, is the 4 Ws. I think it's very important to ask is who will churn, when will they churn, why will they churn, and what is the best treatment. That's very important to ask in any churn-related problem. And then the second takeaway is I think it's important to understand the churn reasons. Besides getting good accuracy prediction, understanding churn reason can help the business to understand why customers are churning and be able to design their offer bundles or drive their business strategy. So it's very important to get explanatory power on the churn reasons. And then the third one is use statistical methods for bias correction instead of the expensive A/B testing. And I also want to share with you that we have also write a blog. This blog is written by Ilya Kasov, head of data science, and myself. For more details, you can look at this blog. And so it's basically having more technical details of this talk. If the URL is too hard to remember, you can just Google Churn Grid Dynamics. That would also take you there. So I want to thank you for attending, and I would leave the rest of time to questions.
Oh, thanks so much, Jake. We got some great questions from the audience. Let's start with, what is the first thing to consider as a metric to evaluate a topic model?
Thank you, Stephanie. Sure, great question. I think this is associated with model validation. I guess the answer depending on whether you have labeled data or unlabeled data. So, for example, if you have labeled data, so you can look at confusion matrix, like how many false negative you have, how many false positive you have in the model outcome. So that is a way to do label data testing. In our use case, we don't really have the luxury of label data, so we look at other criteria for testing our model. So first thing we would look at is when we group the customer into the topics, we want to understand the churn rate on the topic group versus the average churn rate. So in a typical experience, we will see 3 to 5 times higher churn rate in that group comparing to the average group. So that is something that can convince us that we are targeting we are reviewing the right churn reason. And the second, we will look at the coverage, like how many customers cover by that topic, and is that making business sense? And the third thing we did is actually where it took a very long time to do that. It's manual validation process. So for every topic that we have, we would have a couple of call transcript to test on the topic, and then the model will pretty much like scoring the transcript with a dominant topic and the subtopics. And then we go back to the transcript and check whether the dominant topic is actually showing in the paragraph. And then we will also evaluate, whether this is, something that indeed customer is express native sentiments, and which also review the churn reason. So that is a manual validation process that do in model validation. So I hope that answers your question.
Awesome. Yes, thank you. We've got time for one very quick question. Once you segment the audience with needs and wants and demographics, how do you buy media with those targets?
So it's talking about like the demographic, like how do we utilize the demographic in our model, right? Do I understand the question correctly?
Yes.
Okay. Yeah. So like the demographic model can come from like different resources, and indeed I saw research papers that you can purchase those demographic data from social media. That is a possible resource to obtain the data. In our case, we get the demographics from customer records within our client database. So we pretty much just like evaluate those customer demographics and put it to our model, and basically picking whoever that's more significant to our model, and then removing the ones that are somewhat non-significant. And there's also, so I think it depends on industry. There are some regulations using demographic data. Like some industry would prohibit you using things like gender or age that is considered discrimination. I think that is also like a consideration when we're using demographic data to feed our model.
Great, thanks so much.
Yep.
So next we're going to visit with Das Gupta from Saatchi & Saatchi. We'll see you over there at his session in just a few minutes. Thanks again, Jake.
Bye, thank you.